Yeah, we are live, you guys. It's Friday. We're still like in lockdown, but we're going to make this work. So, what happens if you're not doing your homework or doing anything? So, take a look. If you are doing it, you are awesome. You are a rock star. You're going to get a good grade. But if you're not doing anything, you might want to tell some of your friends if you see that their names are there, that they may have to take the course again, because I can't grant credit for geometry if there is no work. If you haven't done geometry, you can't get credit for geometry. Anyway, I'm calling parents left and right. So first of all, let's take a look at last night's homework. And again, you need to show work. So I didn't do a lot of work because, you know, these are just the answers, but you need to show work. Okay, so here's number one. I graphed it, and I got two points of intersection: -5, 6, and -1, 2. Number three, I just graphed it on my calculator or on Desmos, and I got 0, -0, 1, and 2, -1. And then on number 5, I graphed it. Again, you graph it on your calculator or Desmos. 0, -2, and 3, -2. And then on number, let's put it this way a little bit, shift it up. On number 7, I just solved it and factored, and I got two answers: -2, 6, and 2, 6. Number 9, I just solved it and factored it, and I get -2, -6, and 0, -4. Same thing on 11. I just solved it and factored it. I set them equal. So if you're not sure how to do it, again, I'll show you. You just set them equal, like on 11. I would have gone x squared plus 3x minus 5 equals a 3x minus 1, because they both equal y, so they can equal each other. I'll bring over everything, and I'll have an x squared. If I subtract 3x, it's gone. If I add 1, I get a -4. That'll factor into an x minus 2, x minus 2. So one answer is x plus 2, x minus 2. So I get 2 and -2, and then I plug it back in. Probably that's the best one to plug it into to get the corresponding y value. I thought you needed the quadratic formula on this one, but you didn't. This one actually works, so you can set them equal again. You've got, I'll do this one down here, scratch that out. So -6x plus 14 equals x squared minus 9x plus 16. Bring everything over that way. So if I add 6x, x squared, if I go plus 6x, I'll have a minus 3x. If I go subtract 14, I'll have a minus 2, plus 2, sorry. And then that'll factor into an x minus 2, x minus 1, so x equals 2, and x equals 1. And then I'd probably just plug it into these answers into this equation to get the corresponding y value. So anyway, that's how you do it. So easy. Hopefully you guys are showing your work. See the work. See I showed work. See I showed my work. Okay, no work, no credit. Okay, now as far as today. So today we're going to do two different things that are kind of go together. Okay, so today we want to talk about inequalities. So today's date is 3/27, 2020, and we're going to talk about inequalities. And again, if I get going too fast, just pause the video. Okay. So inequalities are the greater than or equal to, less than or equal to. Okay. So with inequalities, you can have a lot of answers. Just a really brief answer, real quickly. N is, say, greater than or equal to 3. Okay. Well, we're not doing these, but think about it. What's greater than or equal to 3? 3, 4, 5, 6, and all the decimals in between. So, I mean, if I were to put this on a number line, and I had 0, 1, 2, 3, I would have all of these answers. So what I would do is make a darkened circle, and I show a darkened arrow, okay, because 3 is an answer. It's greater than 3, or equal to 4, 5, 6, 5.1, 100.3, 2056, 2, 3 and 2/3. All of these answers are shaded, okay, because it's got a lot of answers, okay. So that goes back to Algebra 1. We're going to do things more with our quadratics instead. So let's take a look at the first example that we want to do. So this is with quadratics now. Quadratics are our x squared equations, okay, quadratics. So let's take a look at example 1. Example 1, I am going to solve x squared minus 2x minus 8 is greater than or equal to 0. Okay? So, well, I'm going to solve it, but the thing I know is that there's going to be lots of answers. So I'm probably going to need to show my answer on a number line. But before I do anything, let's find what I call my border points. Like 3 is a border point, right? That's where it starts. So to get the border points here, I'm going to solve for x. Okay, so to solve for x, let's factor first. Okay, so I'm going to set it equal to 0 because I'm looking for border points. And I'm going to factor. Okay, so if I factor, I'm going to go x and x because that makes x squared. Multiples of 8. Let's use a negative 4 and a positive 2. Negative 4, positive 2. Because that together makes my negative 8 when I multiply and negative 2. But these are just mini equations, so x minus 4 equals 0 and x plus 2 equals 0. And then what I'm going to do then is solve. I get x equals 4 and x equals negative 2. Okay, so now I know that since it's an inequality, there's going to be lots and lots of answers. So I want to put the answer on a number line. Okay, it's the only way to really show the answers here is with a number line. So if I go my 0, there's negative 2, 1, 2, 3, 4, there's 4. I don't need all the points in between. I know where they are. So, a couple of things. First of all, this has an equal sign to it. But because it has an equal sign, I'm going to do a solid dot. So I'll do a solid dot at negative 2, and I'll do a solid dot at 4, because negative 2 makes it equal, and positive 4 makes it equal. Now, the next thing I have to know is what other answers work. So I'm going to choose some points, okay? So if I choose, I'm going to choose any point to see if it works except for my border point. So first of all, let's choose negative 3, okay? So if I plug in negative 3, let's see. Let's plug negative 3 into the original. Take negative 3 and I plug it into my original equation. Let's see what happens. So I'll have a negative 3 squared minus 2 times negative 3 minus 8. Is that greater than or equal to 0? Well, let's find out. Use my calculator. Why not? Let the calculator do the work. Okay. I'm going to have 9 plus 6 minus 8. And I get 6. So I get an answer of 6 is greater than or equal to 0. Is that true? Yeah, that's true. Which means everything in this region, negative 3, and everything in this region should work. I mean, I could test more, but it will work, okay? So you shade everything there, okay? All of those answers work, okay? Now, how about 0? Well, I could test 0. Okay, x equals 0. So if I go, okay, and plug that in to the original equation. So I'm plug 0 in, up in here. So I'm going to go, okay, 0 squared minus 2 times 0 minus 8, is that greater than or equal to 0? Well, that's going to be negative 8 is greater than or equal to 0. Is that true? Is negative 8 greater than 0? No, it's not. Negative 8 is not bigger than 0, so I do not shade that region. So let's try the next region. Let's try 5. So, I'll plug in 5. So I'll have into my original, I'll have 5 squared minus 2 times 5 minus 8, is that greater than or equal to 0? Again, I'll just use my calculator. Calculator does it so nicely for me. It's so easy, so clear. I'm just going to go, oh, let's see, 25 minus 10 minus 8 gives me 7. Is 7 greater than or equal to 0? Yes, that's true. So I want to shade 5 and everything beyond. Now, here's what we're going to know. Okay, listen, this is important. This will help. Okay? If it's greater than, it's an or statement, and they're going to shade opposite directions. Here's another thing that helps. You're going to shade every other region. Okay? If it's an and statement, we're going to shade in between. So, let's take a look at it. So this is actually the answer. The answer is the graph, because the graph shows all of these x values that will make this statement true. Okay, now let's take a look at example 2. Okay, example 2, let's do an and statement. So if I have an x squared minus x is less than 6, well, the first thing I want to do is because I need to make it equal to 0. Let's make it equal to 0. So if I make it equal to 0, I can factor. So let's bring over the 6. Let's go ahead and subtract 6, right? Minus 6 minus 6. I'll rewrite this as an x squared minus x minus 6 is less than 0, okay? Okay, to make it easy to graph and to factor, I'll put a 1 here, my invisible 1, and factor. Okay. I'm going to use an x and an x. I'm going to use a negative 3 and a positive 2. Now I'm going to let it equal 0 for a bit and find my border points. Because I know I'm going to put my answer is going to be on a number line. So I got to find my border points. Well, that's easy. If I solve for x, x minus 3 equals 0, x equals 3, right? You guys can do that. I've got x plus 2 equals 0, or x equals a negative 2. So I'm going to go to negative 2 and 3, right? Now in this case, my border points are going to be open circles because there's no equal sign. We've talked about that a little bit before we did piecewise graphs. So open circle and open circle on my border points. Now, let's test a point. Well, the easiest point test is always 0. And because it is going to be an AND statement, I probably am going to shade in between, but I'll prove that to you, okay? So we take x equals 0. Let's plug 0 into the original equation, okay? All the way up here, okay? So I'm going to rewrite it as a 0 squared minus a 0 less than 6 is 0 less than 6. Yes, that's true. 0 is less than 6. So you want to shade 0, okay? And everything in between, okay? Now you'll find if you test the other points, they won't work. You'll learn that if it's an less than, it becomes an AND statement. Shade in between, unless there's a negative, and you got to be careful of those. And you shade another region. Okay, so this is my answer. It's all of these points, which is an infinite amount of points between negative 2 and 3. All of these points will work. They'll all give you a true statement. Okay, now that's not too bad. Now let's take a look at the next part. So the next part deals with graphing on the XY plane. Right? This is actually easier because we're going to let the calculator or Desmos do some of the work for us. Okay? So let me start off with the first example. So this is example 3. If you have a y is greater than or equal to x squared minus 5. Okay? Now this one's different because you've got the y in the equation. So once you put the y and the x, you put it on the xy plane. Okay? On these, there is no y value, it's just the x value, so it's just on a number line. Okay, see the difference? No y value, it's on a number line. Okay, y and x, it's on the xy plane. Okay, so how do you graph this? Well, first of all, I need to graph this line. So I kind of know what it looks like, but if you don't, you can put it on your Desmos. But I'm going to go down to negative 5, 1. I'm going to go down to, let's see, what color do I want? How about red? 1, 2, 3, 4, 5, and I know it looks like this. And again, if you're not sure, you can check it out on your calculator or Desmos. Rally helped me out with getting my contrast on my Desmos. Let's see if you guys can see this now. Okay. Thanks, Rally. Oh, you can see it. Look at that. Thanks, Rally. So if you wanted to go y equals x squared subtract 5. There it is. Exactly like I just, hey, what do you know? Exactly like I just put, okay? Now, the difference is this greater than sign, okay? So, here's my line. It says greater than. What points are above my parabola? It'd be everything inside. So here's my parabola. Don't think of what's inside or else, I just think above my parabola. So I went above my parabola. From above, because it's greater than, that says greater than. I'm going to shade everything above my parabola, which is everything inside it in this case. So that's my answer. It's an infinite amount of points, okay, all of these points would satisfy this condition. You can pick any point to prove it. Let's pick, for instance, this point right here, which is the point 1, 2, and if I were to plug that into my original, I'd have 2 is greater than or equal to 1 squared minus 5. 2 is greater than or equal to 1 minus 5. 2 is greater than -4. That's true. Okay, so any point within this region will work and give you a true statement. Okay. All right, I'm going to turn the page. Okay, let's turn the page quite a bit. Okay, all right, let's take a look at another example. Okay, example 5, I think. I have a y is less than x squared minus 3x. Okay, so it's x and y. So I know, because it's x and y, I'm going to put it on the x, y coordinate plane. So how does it look? Well, I kind of know how it looks, but if you don't, try your Desmos, okay? So, all right, so you don't know how it looks. Get rid of all that. We'll go x squared, subtract 3x, and there it is, okay? So, here's the thing. Be careful on this one because it says it's less than but not equal to. So it does not equal the line. So how do you show that? Well, you're going to make a dashed parabola line like this. Okay? Doesn't have to be perfect, but I'm going to make a dashed. See, I make a dashed. The reason it's dashed is because there's no equal sign right there. So it's a dash parabola. So still there's a border. And now this is less than. So when I think about less than, that is less than, I have to shade everything under the parabola. Everything under the parabola is below it. It's kind of like at the outside, but you want to think about below. So shade everything below it. And all of these points will be solutions to what I have. Okay, there you go. That's my answer. Okay, now, last but not least, what happens if you have two of them together? And it's not that hard because you're going to let the calculator do most of the work for you. Okay, example 6. What if you have this? You have y is less than or equal to negative 2x squared, and y is greater than x squared minus 3. Okay, so I do have x and y's, so I do know I'm going to do it on the coordinate plane, x, y axis, because I've got y's and x. So then what I'm going to do is this. I'm going to graph the first one, and again I can use Desmos. So I can go straight to the first one. I can go negative. Does negative matter on the Desmos? I guess I'll find out. Negative 2x squared. Nope, doesn't not seem to matter. There it is. And then I can put in a second equation. Okay. And my second equation would be a y equals an x squared subtract 3. There they are. So let's try and get that on my graph. So the first one I'll do in blue, kind of like my Desmos did. I'll do this one in blue. So start, and it's going to look like this. Okay, and a solid line. It's going to look like this. There we go. Okay, there's my first one. There's y is less than or equal to solid line negative 2x squared. Now it says less than, right? So I'm going to shade everything below the parabola, which is all of this. And let's shade the other one in red. Start at -3. Okay, there it is. And it's going to look like this. Oh, I'm not -3. There's -3. Almost made a mistake. Hate it when I do that. Oh, it's all good. And this one's going to be dashed because there's no equal sign. Dashed. And since it's greater than, it's everything above your parabola, everything above the parabola, which is all of this. What we want, again like yesterday, the day before, we want all the stuff where they overlap. So my answer is just in this region here only. So I'm going to make that darker than all the rest. And that is the solution. Now that's an infinite amount of points, but it's a closed region. So I'm going to darken it more than the rest. And that's my answer. That's how I show my answers, by making it a little bit darker than all the rest. Okay, that's what I have for today. Your homework, and again, no work, no credit. You have to show the work. Let me show it to you. Let's see. Here we go. So we're going to go to page 153. We're going to do 5 through 16 all. Okay. So with 5, x, y, so you're going to put it on the graph. So you let Desmos or calculus, so you can graph all these. You're going to shade, 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 solid line, dash line. Okay. 9, story problem, and I want you to try it. It's not that hard. 10, same thing. You're going to shade, and you're going to shade twice. And you find out where they overlap. 11, you're going to shade twice, and find out where they overlap. Sometimes if they don't overlap at all, then there's no solution. Okay. 12, you're going to graph, shade, find out where they overlap. Okay. Then finally 13, 14, 15, you're going to need to solve and put the answer on a number line. 14, you have to solve, put the answer on a number line. 15, you have to solve, put the answer on the number line. And then 16, give it a try. It's not really that hard. You might need the quadratic formula to do it. So good luck to you. We are going to have we're going to have a test on Tuesday, review on Monday, test on Tuesday. And again, like I told you guys, if you just work at this, I'll help you get an A on that test. Okay, so that's all I have.